All right, what's up, my mathletes? This is Mr. Muscarella coming at you. And in this video, we're going to go ahead and talk about solving trig equations by looking at the unit circle. This is part 2 where we take a look at examples 3 and 4. So let's just kind of recap here a little bit and see what we've got going on. Now, one of the things that we want to be sure to look at when we do that is make sure we have that unit circle around. This can be very similar to what we did before in examples 1 and 2. So make sure you have that unit circle close by because it's going to be super duper helpful as you go through this. Now again, one of the things you want to emphasize while doing this is just like anytime you are solving equations, you want to be nice and neat and organized and all the things, right? So that's going to be super duper critical to your success here in this unit. Now, when the very first thing that you do, now this one, example 3, this one's going to be a little bit more work here because we've got this fraction that's here. So you can do this any number of ways. One of the ways that I'm going to do is just get rid of the fraction. So what we're going to do is put a nice big beefy bracket around all of this. In the fraction part, we're going to look at the denominator. So we're going to look here at 3, right? And we're going to multiply everything through by 3. So when we do that, we're going to end up with the following. So you have to make sure that you distribute the 3 to each term here on the left side. So 5 times 3, of course, we know that that is 15. 3 times cotangent of theta will just be 3 cotangent of theta. And then equal sign. Now, what happens here on the right side is that the 3 in the denominator will cancel out with the 3 that you're multiplying by outside the big beefy bracket. So what's going to happen is the numerator is just going to drop down. So 15 plus square root of 3. Boom, diggity done. Now from here, what you're going to do is you're just going to subtract. So we're going to, remember, we want to isolate the trig function, which in this case is just cotangent of theta. So we want to get that all by itself. So first we will move the 15 on the left over to the right or vice versa. It doesn't matter because they will both cancel out. So this 15 and that 15, they're both going to cancel out and leave us with just 3 cotangent of theta equals square root of 3. Dividing both sides by 3, we're going to end up with cotangent of theta equals square root of 3 over 3. All right, not so bad. So now we've got the cotangent function. Now cotangent isn't anywhere on the unit circle. Tangent we can see there. So there's a couple different ways you can approach this. Now one of them is using a trig identity or a trig relationship here with your x and y coordinates. So you can think about it that way, or you can simply take the reciprocal of both and know that the reciprocal of cotangent, of course, is tangent. So you could say that, and then take the reciprocal of the other side also, and the reciprocal here would be 3 over square root of 3. Now, some people might have this memorized, right? They might have what this would simplify down to memorized. So if you do, no big deal. You can just go ahead and say, all right, well, that would just be multiplied by square root of 3 over square root of 3. And then you'll notice that the square root of 3's will both turn into a 3 in the denominator. And then the numerator will be 3 square roots of 3. But alas, that cancels out. The numerator and the denominator have a 3 going. And so when we're finally done, we'll just get tangent of theta equals square root of 3. So I can just simply look on my unit circle right now and go, oh, square root of 3, where's that? Well, that happens to be up at 2 spots that we see. So one of them, so I'm going to highlight it here in green. So there's 1 square root of 3. So at this relationship right there, we're at 60 degrees and pi over 3. And then right across from that, all the way over here at 4 pi over 3 and 240. So those are going to be the 2 spots that are answers. So pretty cool. So we can go ahead and do that. So then theta, oops, forgot the angle there. So theta would be equal to either 60 degrees or 240 degrees, as well as, now we have to put it in radians as well. So that's going to be pi over 3 and 4 pi over 3. So those would be our 2 answers, 2 in degrees, 2 in radians, for where the angle would satisfy this equation. So we want an angle of 60 degrees or 240 degrees or pi over 3 and 4 pi over 3. So if you want to pause, let me get that out the way and go ahead and do example 4. Go ahead and do that. Again, keep your work nice, neat, and organized, equal signs lined up, and I'll see you guys in a moment. All right, so if you're joining us and you want to do this together, you would move the 2 over, of course, so secant of theta is 1, and secant's not on the unit circle. However, cosine is, so you take the reciprocal of secant, and you retake the reciprocal of 1, and of course, the reciprocal of 1 is just 1. So I want to look everywhere on the unit circle where my x-coordinate is 1, because cosine is the x-coordinate. So the x-coordinate being 1 occurs at, and this is where you got to be really careful, because there are 2 spots, right? Right here, 2 spots. So at 0, 360, 2 pi, and 0. So one of the things that's really, really careful, so you have to go back and look back at the directions, right? And the directions say 0 to 360, but the 360 doesn't count because of the inequality symbol. So 0 is less than equal to theta is less than equal to 360. So that means when you got to be really careful here. So when you write your answer, only one of those 2 answers, 2 values, is the answer. So just 0 degrees. The 360 does not work because of our domain restriction. And then the same thing in radians. So in radians, that's also 0 pi, but you don't write the pi, you just write 0. And that's a wrap. So that is example number 4 right there. So your radian and degree are both the same because they are 0. So that's it for this video. Thanks so much for watching. You guys make it a great day, and I'll catch you later. Peace out.